Let's take a look at the Quiz Yourself questions for Chapter 5. This is Section 5.1. Question 1, number A, reads, write the Egyptian numeral for two pointing fingers, one lotus flower, 3 scrolls, 4 heel bones, and 2, 4, 6 stroke in Hindu Arabic notation. And for B, write the number 241,536 using Egyptian notation. Now we have 2 pointing fingers. So we have 2 groups of 10,000 plus 1 lotus flower, which is 1 group of 1,000 plus 3 scrolls, which is 3 100 plus 4 heel bones, which is 4 10 plus the 2 4 6 strokes, which are units. That gives us 20,000 plus 1,000 plus 300 plus 40 plus 6, which yields 20,000, 21,000. 21,346. Now we want to write the number 200,000 as 2 tadpoles. Four of the 10,000, which were the pointing finger. We need 4 of those. One of the thousands, which was the lotus flower. 5 of the hundreds, which are scrolls. 3 tens, which are heels or heel bones, and 6 strokes. Looking at number 2, we are asked to perform addition and subtraction using the Egyptian notation. If we add for number A, then we have the result of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 scrolls. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 scrolls. We also have 1, 2, 3, 4, 5, 6 heel bones. 1, 2, 3, 4, 5, 6. And we have 2, 4, 6, 2, 4, 5, 11 strokes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. Now what we are going to do is we're going to take 10 scrolls and trade that out for a lotus flower. And we'll take 10 stroke and trade that out for a heel bone. So for part A, our final answer will be a lotus flower, a scroll, 2, 4, 6, 7 heel bones, and 1 remaining stroke. So first we gather, then we regroup like symbols to the next base 10 number. And when we subtract, we try just to cross out what's below with what's above, but we've run out of units. So we'll need to trade out one of our heel bones for 10 stroke. And also when we go to subtract the scrolls, we don't have any scrolls to subtract from. So we'll need to borrow one of the lotus flowers and give ourselves 10 heel bones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I've traded out 1 heel bone for 10 strokes, and I've traded out 1 lotus flower for 10 heel bones. Oh, that was supposed to be scrolls. All right, let me redraw that. Scrolls. Traded out 1 heel bone for 10 strokes. We wanted to trade out a lotus flower for 10 scrolls. Okay, now we're on track. All right, now let's cancel with a different color. Now we can take 1, 2, 3, 4, 5, 6, 7, 8 strokes away. Take these 2, and then 4, 6, 8 strokes away. We can now take away 3 heel bones. Take away 3 heel bones. We can take away 4 scrolls. Take away 4 scrolls. And we can take away 2 lotus flowers. So what we have as a result of this subtraction is 2 lotus flowers, 6 scrolls, and 1, 2, 3, 4 strokes. We have no heel bones left. On Quiz Yourself 3, question 3, we are asked to represent 25 as the sum of powers of 2. So first, let's list out our powers of 2. 2 to the power 0 is 1. 2 to the power 1 is 2. 2 squared is 4. 2 cubed is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. And 32 is bigger than 25. So that one's too big. So if we form 25 with our smallest possible combination, we have 16. Let's see, 16 plus 8 gets us to 24. 4, and then a 1 would get us to 25. So if we have 1 plus 8 plus 16, then we have a sum of 25. This is then a 1, 2 to the power 3, right, and a 2 to the power 4. But we'll just leave it with the 1, 8, 16. What if we wrote it in the other version, we might be thinking more in terms of binary. All right, so 1 plus 8 plus 16 would be our answer. All right, and now when we look at doubling, we'll make a little table. We'll have our power of 2, and we'll say times 43. Because our power of 2 is how we'll talk about the 25. All right, so first, one copy of 43 is just 43. But 43 doubled is 43 plus 43, or 86. 86 doubled is 172. 172 doubled is 344. And 344 doubled is 688. All right, we need the 1, we need the 8, and the 16. Because our number 25 is represented by 1 plus 8 plus 16. Now what we have is actually an illustration of the distributive property, which I like this method. So 25 times 43 is 1 plus 8 plus 16 times 43, which is 1 times 43 plus 8 times 43 plus 16 times 43, which is what we have on this side. 1 times 43 is 43 from our table. 8 times 43 is 344, and 16 times 43 is 688. $1,075. Now I'm going to throw that in a calculator and just double check ourselves. Yep, 25 times 43 is in fact 1,075 according to the calculator. So I like this method because 1, it has the aspect of binary to it. 2, it definitely uses some elementary ideas from the math ed class about breaking up our number 25 and using the distributive property. And then I like the fact that the table that we use in the doubling method gives us the components that we need. So all in all, I enjoy this method. Quiz Yourself 4, question 4, asks us to identify two errors made in writing the Roman numeral LDILD. Okay, so if we take a look at the chart, right, we have I, V, X, L, C, D, M. That is 1, 5, 10, 50, 100, 500, and 1000. Now, L is 50, D is 500. One mistake is we can't subtract the numbers with 5s in them. We can only subtract using base 10 numbers. So we can't subtract with an L for starters. And then we go I, which is a 1, L, which is a 50. The subtraction rule only lasts until the next base 10 number. So we aren't allowed to subtract from the third next value. So the first mistake is in having tried to subtract one of the non-base 10 numbers. And the second mistake is having tried to go 3 places beyond where you are, because you're only allowed to subtract up till the next base 10 value. Convert, for part B, convert DXL to DXL VII to Hindu Arabic notation. Brought the chart back up here. Okay, so in our chart here, then let's take a look at D. D is 500, X is 10, and L is 50. So this goes together as a subtraction. We take 10 away from 50 for 40. And then we move on to the V. The V is 5. I is just 111, right? All right, so what we end up with is 500 plus 40 plus 5 plus 3, or 548. So we've looked at the subtraction rule, we've looked at just the basic combination, and now we have the rules about the thousand and the 100. If we have bars around our number, so the xi is 9 because it's telling us to take 1 away from 10, right? Take 1 away from 10. And so we have a 9, and then we have bars on each side, vertical bars. So that's actually telling us 9 times 100 for 900. So Ix with bars on the side is 900. A bar across the top is 1,000. So here we have 5, the V is 5, times 1,000. That's what the bar on the top means. So 5,000. And those are the 4 quiz yourself questions for section 5.1.